Relays are one of the most simplistic components, but they are also one of the most important, because relays are the link between low-powered digital electronics and high-powered devices. Relays allow digital circuits and digital microcontrollers to switch high-powered devices on and off. In the circuit that you can see here, this main component here, this is the relay, and a relay basically consists of a coil which builds up a magnetic field when current is passed through it. So what happens is, if I run a small amount of power through this magnetic coil, which would be inside a relay, it actually generates a small magnetic field which will actually magnetically pull a switch into the closed position to allow current to flow from the other side. And I'll demonstrate this now. What we actually have here are two different circuits, and the only thing between them is this relay. They're actually both electrically isolated, meaning that this side of the circuit is not electrically connected to this side of the circuit. So I have a DC power source here which is running at 3 volts, and on this side of the circuit I have an AC power supply which could be high power. It could be the full AC mains voltage, it could be 120 or 240 volts, and it's connected to this lamp. So what happens is, by switching on this circuit, which could be me switching it on, or it could even be a digital microcontroller that switches it on based on a program or instruction that I give it. But for the sake of simplicity, I'll be turning the switch on the low powered side, and just have a look what happens. So you can see what's happened here. I flip the switch on the low powered side, which is a completely separate circuit. You can see the electrons do not flow onto this side, and the switch on this side here was magnetically attracted towards the coil on the other side, because there is now a magnetic force pulling this switch towards this closed position. So it's allowed this AC circuit to run this lamp, and the lamp is flashing because it is AC and it is running in slow motion. In real life, that lamp would be flashing so fast you wouldn't be able to see it. So let's just have a closer look at that again. Focus on this portion of the screen, and on the low powered side I'm going to flip the switch and watch what happens. The switch was magnetically attracted towards the coil, but both of these circuits maintain complete isolation. They are two separate circuits. Now, the reason why relays are so significant is because it allows digital devices, processors and computers which run at a very low power to control high-powered electronic devices such as motors, heavy industrial machinery, and many other things, basically allowing computers and microcontrollers to interface with these much larger devices. And there is an example of this which I will show in the future, where I used an Arduino, which is a low-powered device which runs off of 5 volts. I used an Arduino to run a bit of code that interfaced with Bluetooth from my phone, and that meant that I could send a command from my phone to the Arduino, which would then activate a relay, and then the relay would turn my bedside lamp on. And that's what relays are for, from small projects like that to huge industrial high-powered devices. You will find relays in many places. They are the main component, allowing low-powered digital electronic devices to control any other high-powered device or appliance.